So imagine we have these two equations, equation 1 and equation 2, and we're trying to solve for x and y, sorry. So the easiest way of doing it is by removing one variable so that you are left with the other variable. So how can you remove one variable? Well, you need to make sure that these variables are the same, or they have the same coefficients, right? In this case, we will need to make sure that this one has a 5. So what are we going to do? We're going to multiply the whole equation, the first equation, by 5. Multiply the first equation by 5, and this is what we get. We call it equation 3. And then we come to equation 2. It remains unchanged, so we put it below. Then now we subtract equation 3. We subtract equation 2 from equation 3. It's 5x minus 5. It's gone. X is gone. Then minus 5 minus 3. It's going to be minus 5. And this should be this should be what? Minus 5. That's gonna give us minus 2. Minus 2y. Then 5 minus 13 is gonna give us minus 8. When we divide both sides by minus 2, we get 4. And then to solve for x, we just choose any one of these equations. We substitute. In this case, let's just choose this one. It's the simplest. We're gonna put 4 in place of y. This implies that x is equal to 5, right? Now, let's do another equation, another set of equations. We've got this equation and then this equation, right? And then let's just imagine that you're not allowed to move the numbers of these rows. You can move the rows up and down, but you can't move any other number. Like we can't move this y to this side, then it's minus 4 to this side. So we are stuck with the x. We need to remove the x. Just imagine we just need to get rid of the x. Well, in this case, it was easier because we had a 1 here in the first row, right? So it meant that we look for this coefficient, multiply the first row with that coefficient. We could have multiplied it with -5 or positive 5, but we chose 5. Doesn't make much difference. Just that here we're gonna put a positive here. If we had a -5 here, -5 plus 5 is gonna be 0. So we're gonna put a positive. But in any case, we're trying to get these two numbers to be equal. So we can, one way of doing it is just by dividing this thing, everything here, by 4. And then you're gonna have that 1. Then you can be able to multiply by 5, everything. But it's gonna involve a fraction. If you divide 10 by 4, it's gonna be a fraction. It's gonna make your life difficult. I'm gonna do it, but let's just do this one. The easiest way is just to avoid fractions. So what I'm gonna do is multiply the first number by 5, and then the second row, by 4. So the first row by 5, this is what I get. The second row by 4, this is what I get. And then if I subtract 4 from 3, I get 0 for x. And then 5 minus 16, that's 5 plus 16, which is 21 y. And then 50 minus 8, it must be 42. It means y is equal to 2. Then we can sub we can sub let's just sub into 1. If we sub into 1, we're gonna get 4x plus 2 is equal to 10. 4x is equal to 8, and then x would be equal to 2, right? Now, let's say we didn't multiply, we didn't multiply these things. We divided everything here by 4 so that we can make this thing like this, because let's just assume that's what we did. We tried doing. Let's just do it on the other page. So we had 4x plus y is equals to 10, and then 5x minus 4, y is equal to 2. This is equation 1. This is equation 2, right? So let's just say we divide everything. We take 1, divide by 4. So what we're gonna get here is x plus 1 over 4y is equals to 10 over 4, which is 5 over 2, right? And now let's just leave it as 10 over 4. We're gonna get 10 over 4. Let's make this equation 3. And then just put down equation 5 below. Minus 4, y is equal to 2, right? Then, oh sorry, this is equation 2, still hasn't changed. Equation 2. So now we have a 1 in the first equation. This one, we're looking at these equations now. It's equation 3, but relatively it's equation 1. So in order for us to get the same numbers, we will now need, because we already have 1, we try to have 1 here because normally it's easier when you have 1, right? We will multiply this by 5. Yeah, let's just multiply it by -5 for a change. Let's multiply it by -5 for a change. Multiply by -5, right? So it's going to be -5x minus 5 over 4y is equal to -5 times 10 over 4. And then we're going to have this unchanged equation. It's 4y is equals to 2. So it's equation 2. This is equation 4. Right. And now we have these two x's having the same coefficient. So we can be able to delete 1, destroy it by adding 4. We're not subtracting up because there's a negative here. We're trying to take it away. If we subtract, if we say -5 minus 5 is going to be -10, which is not what we're trying to do. We're trying to get rid of the x. So this is going to be 0. And then we've got -5 over 4 and -5 over 4 plus. So it's going to be plus -4y. Then this is -50 minus 50 over 4. We are adding plus 2, right? You can agree with me that these fractions, they 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 are difficult to deal with. Imagine now if we had a lot of variables, 3 variables, and then a lot of equations, maybe 3. Then we have so many fractions to deal with. I just want to prove to you that it's the same answer. Let me just do a little bit of working. Minus 5 over 4 plus minus 4 times 4 is minus 16 over 4, which is the same thing as minus 4. Just wanted to get the same denominator so that I can just add these two. In this case, we get minus 21 over 4. Then this is minus 21 over 4. Why? Then I do the same thing with minus 50. I'm just going to write minus 50 as minus 25 over 2. Then plus 4 over 2, which is the same as 2. I wanted to get the same denominator. Minus 25 plus 4 will give me what? Minus 21 over 2, right? So let me just make it over 4, which is the same thing, just multiplying by 2 on both sides, which is minus 42 over 4, right? Minus 42 over 4. And then the same, this they cancel each other. Then I'll be left with minus 21 y is equal to minus 42, which is 2, which is what we got. And then by subbing into 1, we get just sub it with 4x plus 2 is equals to 10. Then that means 4x is equals to 8. Therefore, x is equals to 2. X is equals to 2, which is the same thing we got here previously. X is equals to 2, and then y is equals to 2. You see, the same thing, but look at how quick this was and how neat it was compared to this one. We had to deal with a lot of fractions and then on the side, try to figure out what those fractions are, and it takes a lot of time. So the ideas from here are the same ideas that you apply when you're doing Gaussian elimination. Nothing changes. It's the same ideas. You try to avoid fractions, and then you try to make this thing 1. You try to make this thing 1 only if it doesn't have fractions. If it doesn't have fractions, you have to play around with this thing. I'm going to show you tricks. I'm going to do 3 examples on Gaussian elimination. Yeah, let me just stop this video for now.